Lisa LaBelle, everyone!
Yeah. Hello, world. What's up, all you rubber huffers? Huffing some rubber out there. What's going on, all you buttercups? In the midst of doing my little dance, I hit my light. Bear with me. My makeshift studio is falling apart. It's falling apart all around me, but we just keep going. We keep moving on. I hope everyone's doing good out there. It is cold. It has been really cold. There's been some storms. There's been some ice. There's been some black ice. And the trees, they're heavy with the ice. So I hope everyone's staying safe out there. I think we made it through the storm. I know people here in Georgia, well, we were okay up where we are, but in South Georgia, I saw that some people were out of power, so I hope they have their power back. And I hope that everyone has a hold on the power thing soon in the other states where it was real bad. I was watching the Weather Channel with my husband, and there was this girl, there was this girl on there, and she's like, with her co-host, and she's like, yeah, she's talking about the TikTok videos. She's like, hey, you know those TikTok videos where the people dunk their head in water, like with really long hair? They have really long hair, and they dunk their head in water, and then they run outside, and they flip their head, they throw their head back. And her co-anchor was like, yeah, like Dragon Ball Z. My husband's like, who's running the show over there? It's idiocracy. What is going on? That's what they were talking about on a national weather channel. Yes, people on TikTok dunking their heads in the water, and they're running outside in the freezing cold and then throwing their heads back so it looks like Dragon Ball Z. Basically, the hair, it's so cold outside, the hair is freezing up right in the moment, right there, as the hair is flying back. And, I mean, that's pretty cool. It's just funny to hear about on a national weather channel. And if you go and watch Idiocracy, this is what's happening. That's what we're talking about, Dragon Ball Z. And of course, I'm looking outside. I'm like, how these ducks out there in the retention pond, how are they not cold? How their little flipper flops, their little feet, their little flippers, how are they not cold? Those poor ducks. Did you hear that? That was my light. I'm going to bring this microphone down with me as I talk about how I pick the light up. That's a good quality item right there. You hear all that aluminum? Dink, 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 dink. Dink, 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 dink. Yeah, that's a good quality item there, Clark. So yeah, but those ducks it's just like how those little guys just not like freezing, but I did a little reading, and their feet stay near their feet. Stay near to the absolute zero, near freezing, basically. They don't need their feet to be warm. And that's why when they put it in that super cold water, they don't care. They could care less because they're not feeling it. They have minimal alive tissue. Bird feet are mostly bone and tough tendons with very little muscle or nerve tissue, which requires less blood and is less sensitive to the cold. If the feet get too cold near freezing, the bird can momentarily dilate the blood vessels to send a quick flush of warm blood down to prevent actual tissue damage. If a bird foot get cold, it pulls it up into its feathers to warm it up. Those little cute birds. Ever see a little bird perching up on a little branch? And it's just standing up there on one leg, and it's like, just trying to warm its little foot up. I just love animals. I love them so freaking much. The duck's feet stay cold on purpose since they are almost the same temperature as the ice. Very little heat is lost to the ground. That is amazing. Here's the thing. When people talk about evolution, it doesn't make much sense to me, because something like that, think a little duck that is engineered so finely tuned, like a perfectly tuned German cuckoo clock. One of those like made with the black oak, or from the black forest. They get the wood out there, and then you have some clock engineer and like finely tuning a beautiful clock. If you saw a beautiful clock in the forest like that, you're just walking on a hike and you came across this beautiful piece of art that is so finely tuned that if you just one little vibration of the earth will knock it off its path. So are you just going to assume evolution just kind of like came along and just ended up putting a beautiful, perfectly fine-tuned clock there? No. It's just, there's a higher power, God, the Lord, who finely tuned the earth with intention. It's like, it's all intention. It's all too perfect. Our bodies, the way humans are made, the way animals are made, everything is just a little too perfect. And that's my take on it. And I started down that hole with talking about ducks and how they don't get cold in the pond when it's really cold outside. Oh, I saw this here. I'm going to pull this up. Okay. Engine AI, it's a Chinese company. Looks like Engine AI's humanoid is heading to space in 2028 on Interstellar's suborbital spacecraft. So this is what I'm thinking. Okay. They're showing Engine AI and just kind of walking onto the spacecraft. I think the plan is to put humanoids up on the moon, right? So for them to build infrastructure. So you could put 3D printers, you could put humanoids up there ahead of humans to try and help build out the infrastructure a little bit. So when the humans go up there, it's not so daunting, and maybe it will give the humans more of a chance to survive because they don't have to do so much work. I mean, that's a lot. So the thing is, though, are they going to be ready in 2028? That's hard to imagine, and do they have to be? I mean, you're going to test them on Earth. I mean, you could put them in simulation, I guess. You could put them in a world. You could put them in a world model, and that's that NVIDIA Cosmos. That's not the only world model out there, but basically it's a neural network that builds a world around like the understanding of physics in simulation. So maybe you could do that for robots in the moon, but the moon's not mapped out very nicely. We only have like little bits and pieces of it. So I think that's going to be kind of hard. We can imagine what it might be or what it might look like. We have some regolith moon dirt. But as far as like space radiation and are they going to be able, I think they might go up there and maybe fry right up. They may be humming along. Yeah. And then just those gamma rays going to hit them right up their peach and they're just going to short circuit. It's going to be wild. are they going to be powered with one of those, what is it? Isotope radio thermoelectric generator, basically a plutonium-238 pellet in there, just kind of decaying away, and that's how they're going to be powered, I wonder. Initially, there's a lot that goes into it, and maybe it doesn't need to be all worked out because, well, no one lives up there, so their thought might be, hey, space trash. Space trash on the moon. Here we go. My question is, though, I know that China is planning on building a nuclear power plant up on the moon, and then America's like, we are going to do that too. And then we're also planning on putting 3D printers and humanoids up there, not by 2028, not that I know of, because I just can't. That is ambitious. But I know companies like Icon, who I talk about a lot, Jason Ballard over there, he's the CEO of Icon. That's a 3D printing housing company. He is very much interested in getting his 3D printers up there in space to print out infrastructure and buildings before humans go up there. And then you have humanoids like Optimus, who could also go up there and work on a few things. But what happens when those robots and that machinery, say so China's going to send a bunch of these engine AIs, humanoids up there. What happens if they're not ready? The betas, it's just going to be a whole pile of robots, and then, but we're building nuclear power plants and infrastructure and all this. My question is, how much mass would it take for the moon to, how much mass needs to be accumulated for the moon to start affecting Earth? We're tidally locked with the moon. Then how much mass would that affect? I think it might, right? It's got to affect something. I'll have to grok that. But I'm just kind of thinking out loud, and I wanted to ponder this with you guys and see maybe if you're interested or have ever thought about this, or maybe you're thinking about it now and it's very interesting to you. My husband and I, we were watching last week, we were watching a show on Netflix, and it's called Rick Stevens Europe. Anyone see Rick Steven over there? He goes around Europe. He goes around. This is a travel show, and Rick Stevens, he's a renowned traveler and a public figure, and I think PBS might be the one who sponsored him to do all of the travel, and he has a lot of knowledge about all of the things, and so we watched Rick Stevens Europe. And he was over there somewhere over there, I think near Rome or along the coastline over there, maybe Venice. And they were talking about this statue. It was, let's see. There was a religious statue. There was this little town they were in, and look how cute. The town looks so freaking cute. There's not a lot of space over there, so everything's tiny and tight. And that's so cute. And I wonder, though, if the people who used to live there back in that day, a long time ago, if they felt that it was cute. I mean, maybe not. Maybe it felt really tight and depressing. But the sun was shining, so that does something, right? I don't know. Anyway, so there was this beautiful architecture and this church, and this time period was the medieval time period. And they put a statue, whoever these people were back then in the medieval time period, put a religious statue, was of Joseph, I think. And then the guide taking Rick Stevens around was saying that the statue was made by a renowned artist, a renowned statue guy, and probably someone who worked with a lot of iron, an iron worker. And my husband and I were just thinking, how do they know? How did they know it was a renowned artist? How does anyone know anything about history? Anyone could have wrote history. Some schlep could have wrote history, and we're over here like, oh my God, that was made by a renowned artist. Wow, that's amazing. Look at that. And it was like some loser who maybe it was the guy who crafted the statue himself, and he wrote it on the plaque there. He's like, this was made by Ernest Hemingway, renowned artist. Ernest Beowulf, renowned artist from the medieval times. And he was some like, no one liked him. It was like a really bad person or something. And we're like, oh, wow, that's really great. Wow. We don't know. No, we don't know. We don't know. Like, did Aristotle really write those things? We don't know. Plato, what's happening? Some jester could have wrote half of the history that we know, and we're all like, oh, wow, that's really cool. And like people are studying it, and it's just, we just take it with a grain of salt because no one knows. You can't look at history and be like, that's what happened. That's how it happened. No one knows. Heck, we don't even know how half the universe works. How the heck we know how history worked when no one was alive at the time? We weren't alive to look at it at the time. Jeez. Just something to ponder about. So, what else going on? What else going on this week, guys? I hope everyone's staying well. And listen, if you have the flu or a cold or something right now, because it is cold out, and then this is when it happens. Your skin get dry. You come into contact with someone, that virus get up under your dry, cracked skin. Your nose, your whole face holes are drying out, and all the virus, and like, yeah. So you might be sick, and I'm sorry about. I hope you feel better. That's what I'm saying. I'm sympathizing with you. And there was this remedy from 1959 for the flu, and that was a jolly good hot rum punch. From 1959. Just take a jolly good hot rum punch if you have the flu, and a good sweat, and stop in bed until it's all over. So maybe you can go and take that advice, and maybe it will help you a little bit. I think there was something to it. Those people were tough over there. I saw old predictions from 1960. They were predictions of the future. What was it? Oh, predictions for 2026. And this dude, he had a briefcase with a portable printer. I like how printers, by the way, got worse since 1960. But they were predicting all these like this portable printer, and you'll be able to have this, you'll be able to have documents sent to it, and you can have it printed out, and you can go the special agent with the phone in the shoe. Remember that? Get smart. Or but you know what? One thing they did not predict. They didn't predict that everyone be walking around with these rectangles that makes everyone hate each other. Like, where's that prediction? You missed the mark on that one, 1960. I saw, what else going on? I saw Bernie, old Bernie over there. And he was on Theo. And that's Bernie Sanders. And that was an interesting interview. And, it's funny because I think I agree with some things of Bernie, and not most things, but some things. It's like, there's registered nurse shortages, and Bernie was out there. He was protesting with the nurses in New York, and they need more people. They need more people working so that they can help patients. And the answer to that, it's like there's just nurse shortages, and then there's doctor shortages and doctor quality, access. My whole thing is there's not a lot of good doctors out there. and the good ones are not very accessible to a lot of people. So that's a problem. And that's why I look forward to the future. I think AI doctors are the answer for this. And also, I think robots are the answer to nurse shortages. They can help. And you could put robots in a hospital and help out. They can help out the nurses. And I'm looking forward to that. And I hope that I'm being a technology optimist right now. A tech optimist. And I'm looking forward to that part of the future. For sure. What else is going on? I'm trying to get some more a stand-up show, and I hope it happens. And I love being here with you guys, though. I really look forward to doing this podcast with you guys, and I hope that I can't really help anybody like financially with anything because I get zilch from this podcast. But hopefully, once I get something and you guys decide once I'm really good or what kind of value I'm bringing to you, I'm working on bringing as much value to you as I can with this, and then we can get something going. We can move up and move on. And people, they don't want to see you grow, but you got to just keep growing. And, they don't want to. I want to focus on positive things right now, though. So I'm about to run that table. That's what I'm saying. I'm about to run that table, and I'm about to take it all. I'm about to take that first place. I might not know where this ship is going, but people get in on board. And I'm so happy that you guys are here with me today. There's so much to talk about. I'm so excited oh my goodness, there's just so many things happening. This year has already exploded with crazy technology that has come out. Like I'm talking Claude Co-Worker, and that is a AI agentic assistant, and that can help you in your daily life. And it's really amazing. We had got Davos going on. That was going on, the World Economic Forum's annual meeting, which takes place every January, and it was taking place in the small alpine town of Davos, Switzerland. So we have a few things there. And one thing I was pondering too, I saw Chris Paxton over there. That's the AI wizard, and I think that's his professional title too. He posted something that made me think a little bit. Let's see. Bear with me. Was that Chris Paxton? Actually, that was not Chris Paxton. That was someone else. This is another AI wizard. Rex Humaki. Sorry, can't pronounce that last name. Gonna butcher that thing right on up. So we have a post here. In 1966, people shared their deepest thoughts with a chatbot that convinced them it understood, and it didn't. So it was called Eliza. And this guy's just saying that people are trusting AI a lot. And I mean, there's a lot to be said about that, but I think that people might be trusting AI a lot because there's this underlying sense of like hopelessness and despair and depression that some people might be feeling. And it's an underlying force that it's making people turn to AI instead of fellow humans. Fellow human guys, humans want to help. They want to help you. And I mean, not all humans, but most humans are good people, and they will help you. And it seems daunting to go to someone because you might get rejected or this or that. But most of the time they'll take you in and say, hey, look, I can offer some advice here, go there. Or, you know what? Go hug a dog. How about that? There's a lot of lonely dogs. Then they just want some of your love and just go hug one of those dogs, okay? This, people trusting AI, it makes me want to be with people more. Like the more involved I get into AI, I think it's cool. I love using it. And I think it's really awesome and it's a cool tool. But it also gives me perspective that human beings are extremely unique and we have emotions and we have the ability to give off these like neurons and this energy to people, kindness and love and happiness. You can make someone laugh. And that's just super special. Like the more into AI I get and the more research I do about robotics, I am just realizing how special we really are. Us and animals too. Animals are amazing. Dogs, oh man, they're incredible. I mean, any animal, horses, they have this way of showing love. And so I just want to encourage you to talk to people more. Get out and talk to people more. That's all I'm saying. I don't mean to be preachy. Jeez, criminally. God. Okay, let's get some coffee. Let's get going here. Let's get the energy up. Good God. Okay, one more sip. I'm out of coffee. It's okay. I have another one on the other side of the table. Yes, let's go. Okay, so Davos. We have Elon Musk at Davos. I haven't listened to this. Let me see. How long is this? Oh, this is not that long. Okay. Here we go.
We might have AI that is smarter than any human by the end of this year, and I would say no later than next year. Wow. And then probably by 2030 or 2031, call it 5 years from now, AI will be smarter than all of humanity collectively.
We only have a number of minutes left, but I want.
So that's amazing. That's interesting. I hope it happens. And that will be good, especially for the medical world. Because, I would rather have a AI robot work on me than a human being. Because, like I said, there's not a lot of great doctors out there. There's more bad doctors out there than there are good ones, and the good ones are really hard to access. So now you have AI that's going to be way smarter than a human being. I'll take that. Thank you. Moving on. Now we have Howard Lutnick. That's the Commerce Secretary of the United States of America. Let's see. Howard Lutnick just walked into the lion's den and told the World Economic Forum exactly what they didn't want to hear. Let's see. 2 minutes? Oh boy. Let's listen to the first half of this. See what's up.
Okay. We are in Davos at the World Economic Forum. And the Trump administration and myself, we are here to make a very clear point. Globalization has failed the West and the United States of America. It's a failed policy. It is what the WEF has stood for, which is export, offshore, far shore, find the cheapest labor in the world, and the world is a better place for it. The fact is, it has left America behind. It has left the American workers behind. And what we are here to say is that America First is a different model, one that we encourage other countries to consider, which is that our workers come first. We can have policies that impact our workers. Sovereignty is your borders. You're entitled to have borders. You shouldn't offshore your medicine. You shouldn't offshore your semiconductors. You shouldn't offshore your entire industrial base and have it be hollowed out beneath you. You should not be dependent for that which is fundamental to your sovereignty on any other nation. And if you're going to be dependent on someone, it darn well better be your best allies.
Okay, that's not the whole clip, but that's strong. He coming in hot. I mean, the globalist experiment has failed. I agree with that. Lutnick, come on, Lutnick. Let's go. We better get our heads out our arses and get freaking moving. God. Good Lord. Lord help us all. Hopefully we go in this direction, the Lutnick direction over here. Moving on. Okay. All right. Okay. Something that's interesting. I find everything interesting. All of this is so interesting. That's why I talk about it. I listened to a podcast called the AI Daily Brief, and something caught my ear cocula, and that's the thing in your ear, and it helps you hear. It looks like a snail in your ear. Anyway, so something caught my attention, and it was the host was talking about how mentorship at corporations is going downhill. It's going into the toilet. Yeah, it's going away. No one's doing it anymore. The reason why it caught my attention is because my husband, he was talking about this actually a few months ago, I think last year, and he was the first who was talking about this, how the older generation is not, Gen X is not doing much mentoring. And mentoring is a big deal for the younger generation. I know I was looking for mentorship when I got out of college, and it was really hard to find anyone. There was one person, and she worked at the Penn State Hershey Medical Center, and that's where I had an internship. And she mentored me a little bit, and I was very thankful for that. But that was it. That's it. That's all I found. I didn't find anyone after that. So it was even starting back then that no one wanted to do any kind of mentorship. And now I think like people's lives just get so busy, and now we have AI to do our work for us. Basically, we have all these agentic AI means that it basically let me see. Agentic AI, bear with me. It basically means that you give the AI a goal, it takes actions to finish it, and it has quote unquote hands. It doesn't just tell you how to make a budget, it actually creates the file and saves it to your desktop. That's agentic AI. So now we have agentic AI that executives are using, and mentorship is not happening. So here's a little clip of, bear with me. I have to transfer the clip.
Domain expertise is, in other words, extremely valuable, even and especially in this world of code AGI. Having knowledge of the way that work happens in a particular domain, be it a function or an industry, understanding the problems and the constraints within that specific field, which could be anything from governance to compliance regimes to data set challenges, is going to be absolutely key, and even more key in some ways than before. When you are having to think in systems terms, you need that wide-ranging view that only domain experts are going to have. Now, this actually brings up another challenge, which is one that could get more apparent, especially in the medium term, which is that the more that current domain experts use agents to do everything, the less of a pipeline to expanding that domain expertise to new people in the form of mentorship and junior employees, the less they spend time distributing that domain expertise to younger employees in the form of mentorship. We can't take on every problem at once, so we'll skip that one for now, but it is something that I think organizations will start to recognize.
So if you're out there and you are in a position that you can mentor someone, go do it, because it's a dying thing, and young people, they are starving for it. Like young people who are excited about their work and want to get into the minutia of everything. They're looking for someone to help them out, to guide them a little bit, someone who knows something about the work that they are going into. So I would encourage you to go and take 5 minutes out of your day and go mentor someone, because it's a dying art. We're going to need more coffee. Guys, come on. Coffee is the best. All right, I got both of my coffee mugs out here, and just talking about coffee makes me want more coffee. Okay. Good stuff. So we have Claude Code. That's the word on the street is Claude Code. Claude Co-Worker. What's Claude Co-Worker? Well, everyone's talking about Claude Co-Worker. And also Claude Bot. Claudebot. Is Claudebot owned by Anthropic? No, it's not. It's different. And it got renamed to Maltbot, I do believe. So the two things that are, or the two agentic AIs that people are super excited about these days is we're talking Claude Co-Worker and Claude Bot. And Claude Bot is actually renamed to Maltbot, and that's not as fun. But I can see the confusion where people think that Claude Bot is made by the same company that makes Claude Co-Worker, which is Anthropic, different things, but they're both agentic AI. Again, agentic AI is, it takes the AI agent, which is on your computer. It takes actions to so you give it a goal, it takes actions to finish it. It has hands on all your things. It's putting its paws on all your files. And it doesn't just tell you how to make a budget. It actually creates the file and saves it to your desktop. That's an agentic coworker like Claude Co-Worker or Maltbot, aka Claudebot. So these are two different things, though, in the way of Claude Co-Worker is a closed source. It's a closed source AI agent, and that makes it a little more secure, actually a lot more secure. It's on your desktop. It's only on your desktop, available on your desktop. And the Claude Bot is open source. And now they're two different things in the way of Claude Co-Worker. It's for people who, let's see, the use case is instead of spending Sunday matching like receipts to bank statements, you can take pictures of all of your receipts, put it in a file, and then tell Claude Co-Worker to go and match up the receipts to your credit card statement, and it can also make an Excel spreadsheet and do all that. So that's Claude Co-Worker. You're giving it permissions to be in your computer and to put hands all over your files. But again, it's a little more secure. It's in a sandbox, they call it. And a sandbox is basically like imagining the AI is in a literal sandbox, and it can build whatever it wants inside the sandbox, but it can't throw sand like outside of the sandbox, meaning your information. So Anthropic puts the AI in a restricted container. It can see your files because you gave it the key, but it can't go rogue and change your system settings or break your computer. It's controlled and it's closed source. Now Maltbot, Claudebot, is a bot, an agentic AI that you can use to talk to people through WhatsApp. You can use what's the other one? I don't know, because I don't even use WhatsApp. I don't think a lot of people use that in the United States, but it's useful because you can have it text for you basically and answer messages. And that is Maltbot, but that is open source, which means there's a lot more room for scammers to get in there, and that's super risky. There's no like big brother protecting it. It's basically it can't by the way, it can't read your Apple Messages. So only like WhatsApp. And I don't know if maybe Android users can have it look at their text messages. So it's for people who want to be off their computers. So your Maltbot or Claude bot is on WhatsApp, and you can be out somewhere at a football game for your kid, and you're like, oh no, I forgot to send an email to my boss. So you can text ClaudeBot through WhatsApp and say, I forgot to send this document to my boss. Can you find it in the folder, and then email it to my boss, and then it does it. But again, with ClaudeBot, you're going to need your own API. That's an application programming interface, API keys. So it's a third-party open source project created by developer Peter Steinberg. Talking about ClaudeBot. It's not an Anthropic project, even though it has the word Claude in it. Since it's open source and requires you to put in your own application programming interface keys, there have been recent reports of scammers making fake versions to steal credentials. So that is something that I would think someone who knows a lot more about coding and computers and cybersecurity, they might use that, because it sounds like an interesting tool, because you can use it to answer messages on WhatsApp and other applications. But it's risque, quite risque. So Claude Co-Worker, you do not need your own application programming interface keys. They handle all that. Anthropic handles it. You just go, you log in, and you say, here's my financials. I need you to help me with my taxes. Can you do my taxes? I think it can do your taxes, actually. And also, hey, I need a budget for this year. Here's my financials. It will make you a budget. I mean, that's the use cases that I think a daily, like someone in their average life can use it for. And also, if you're someone like me who does a lot of research, you can ask Claude Co-Worker to research things simultaneously, basically like 5 different subjects, which is super helpful, and it makes the summaries of it, and that is super helpful. And also to draft emails and draft emails to go ahead and it drafts an email. You're like, okay, that's great, and then you hit send. So those are the use cases for these 2 very popular AI agentic agents that have emerged from below the surface. They just kind of came up one day out of the core of the earth. And they're like, hello, I'm here to help you with things. And this is our start to 2026. So if these AI agentic agents are doing this type of thing now, imagine what they're going to do in December. So we'll come back to that. Now, Anthropic has gone leaps and bounds. I felt they were kind of an underdog, and that's just what I was feeling probably last year. And then they came out with Thor's hammer, and they're like, I'm taking first place. You see that first place medal? That's mine. And no one disagreed with it. And that's what I'm about to do. That's what I'm about to do with this comedy. I'm about to run that table. You better run that red light. I'm about to run that table and take the prize. Yes. Okay, about to take it all. Bichons. So we got Jensen Huang talking about Claude and how incredible it is. Now, Jensen Huang, he is that black leather jacket wizard of Silicon Valley. Here we go. Oh, the internet wants to be slow today.
First of all, Claude is incredible. Anthropic has made a huge progress, huge leap in developing Claude. Yep. We use it all over our company. The coding capability of Claude, its reasoning capability, its ability is just really incredible. And anybody who's a software company really ought to get involved and use it. first of all, Claude is incredible.
Oh, that's it. Kind of cut off. So they use Claude Code. Jensen Huang, and he makes those NVIDIA GPU chips. He is the CEO of NVIDIA, folks. And that's some serious biznack over there. So that's wild. If you're into this, vibe coding, and I'll just explain real quick. Vibe coding it was a term coined to describe building software by simply explaining the vibe of what you want to an AI rather than writing the actual code yourself. So if you're at all interested in that, you're listening to this, you're like, well, that's interesting. This is interesting. We got happy coding, which is remote vibe coding on your phone. Remote vibe coding means you are running those AI workers on a powerful computer somewhere else in the cloud, basically. But you are controlling them from a mobile phone or lightweight tablet. So, and again, that's called happy coding. And I think that uses Claude Code. And I could be wrong about that, but I'm pretty sure it does. Talking about Claude coding. Man, it's really, really making its way out there. Okay, moving on. Oh, I saw this little robot. It's just the cutest thing. I didn't do any research on this, but this is a robot I'm going to show here. But I've shown you guys a robot that was biomimicked from an ostrich, and it had just one leg, and it was just like bouncing on that one leg, and it had the quadruped rotors. It was a quadricop, and it was very loud. It was like, but it would like jump off of a thing and then kind of like float down to the floor and then float up. So we have another little one-legged fella over here called Salto. And shout out, I have a follower on TikTok, and he sent this to me, and I thank you for that. That was really cool because I love this little dude. He's here we go. Let's see what's up with him. With a hop, skip, and a jump, high-flying robot leaps over obstacles with ease. Salto, the jumping robot, can navigate an agility course and even take a jaunt through the Berkeley campus. And Berkeley, we're talking about over there in California. That's a Berkeley, University of California. Salto, the jumping robot. Here we go. So cute. Can navigate an obstacle course with ease and go on walks through Berkeley campus. Okay, so this is legit. Since the first unveiling of Salto in 2016, UC Berkeley researchers have upgraded the robot with a host of new abilities. Now it can navigate an obstacle course with ease and go on walks through Berkeley's campus. I would love to see this little one-legged dude. You know, this one-leg dude. You know, he like those birds and those branches, trying to keep their foot warm, putting their little foot up underneath their little feathers. That's just trying to keep their little foot warm. That's what this dude is. He's just like bouncing around on one leg. Doing, 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 doing. Okay, here we go. We'll just play this.
Salto is a little 100-gram robot, and it's only about 1
rotors.
foot long altogether. But we think it
two
can do
little
a bunch of
rotors on
really
it.
exciting tricks.
That's so cute.
I have been working on Salto for almost 4 years. It's been so much fun the whole way through.
There's
With the first version of
Salto.
Salto, we demonstrated that it can jump once off the ground and then again off the wall.
Oh, up, do some parkour.
Now with the
here's
newer version
here's
of
my thing. We're
Salto,
not gonna watch this whole thing. It's like 5 minutes
It can
long.
run for up to 10
It's so
minutes at a
cute.
time,
Look
or
at this
even a little
thing.
bit more, and do
it's like
hundreds
little
of jumps in that period.
Ding, 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 ding.
Its maximum jump is about 4 feet high
Whoa, 4 feet high.
and can run
Look at this
8 or 10
dude.
miles an hour,
That's
which is pretty
oh
fast
my gosh,
for a
10
little.
miles an hour. It's just dinking
It
along.
can clear obstacles
like dink dink.
by making really large
Doink,
jumps
doink.
or by jumping far.
Boing, boing.
It can even follow a moving target if we tell it where it is.
Wow, that's insane. This is the first time I'm watching this video. That is insane. It could follow a moving target. Oh, that's one little leg. That's a little dink dink leg.
Probably better than any of our other robots we've had so far.
That is so
cute. Let us move on surfaces.
You know why it's cute? Because it's small. It's cute because it's small. Now, if that thing was bigger.
3, 2, 1.
What's that? Oh, no. It just like unraveled. Its retractable leg.
Almost a dozen cameras on the scene.
That's amazing. That's so cute. It started off on the ground and its leg was like folded up and then it retracted almost and then it started dinking along. Now, again, if this thing was bigger with big old rotors, like two rotors on the side of it, that'd be a little, no. I'd say no. No. I can't imagine something like that walking up behind me. You know, maybe it went in with that Clearview AI facial recognition, but then it got your face wrong. So then now you have this ostrich one leg rotor thing coming up behind you to get you and take you in. And you're just like, what? You're looking at this thing like, it's louder and it can jump really high. If this thing was bigger, that can jump a lot higher and fly a lot faster. No. But this little Salto is the cutest thing in the whole world. It looks like a little bird. So what I would like to see is this little retractable leg and boinky thing, dink dink. I want to see dink dink on my phone. And I'm talking a retractable leg on my phone. So it comes out of my phone and my phone follows me around dinking along. What do you think? That would be so fun. I would love that. Can we get a retractable leg on my phone so it can dink dink and follow me around dink dink style? These two rotors, we got two rotors can come out of the top of your phone and then a retractable leg at the bottom of it. Be like, all right, phone, let's go. We're on the move. Ding, 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 ding. Because sometimes you walk all the way up the stairs or all the way down in the basement, and guess what? You left your phone on the other level. And now you gotta go up or down to go get your phone. And we're in 2026, so I think our phones should have the ability to follow us around. Just that leg come out, pink. Little rotor, pink. All right, little buddy, let's go. We're gonna go to the store now. Ding, 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 ding. Everyone's dogs would be going crazy. Everyone's cats would be going nuts. But I think that's so cute. Moving on. Okay. I'm going a little out of order here. That's okay. Okay. Here we go. This is the star of our show. Yes, we have a star of the show over here. That's super exciting. Oh, yes. All right. This is Hans device worthy, of course. So here we go. And why are we putting our Hans device on? We're putting our Hans device on so our head don't snap off our neck when we see this video. And this is a video of Figure running. Figure is out there running. Holy smokes, holy smokes. We're talking Figure. I talk about Figure all the time. This is a company I've been following ever since they have started building Figure the robot. I've been following Brett Adcock for a very long time. And Brett Adcock over there, he's the CEO of Figure. And Brett Adcock, he's the Luther Vandross of robots because he's smooth. He's a smooth talker with those robots. He talks that robot language. He talks those math calculations. He's making his own in-house batteries. He's doing what that guy was saying, the senator, about making things in-house. And over here in America, not relying on other countries to make the thing. So that's what Brett Adcock's doing over there. They make their own batteries to power Figure. They also made their own AI called Helix, which is the brain of Figure. And that makes him the Luther Vandross of robots. Yes. Okay, here we go. That Brett Adcock, he's running with his robot. I mean, that is a flex, man. I build robots, and now I run with my robot. Yes, that is great. Brett Adcock, what's that last name over there? Is that Comanche Indian, that last name, or is that Saskatchewanian? What's that? No, he from Illinois. I do believe. And Brett Adcock, he used to wear those cowboy boots, but now he wears those Kenneth Cole tech sneaks over there running with his robot. That's what he's doing over there now. So here we go. I'm going to play this is so exciting. Here we go. Let's see. Let's get some sound on this. They're running in the parking lot over at Figure over there. Oh, internet, why are you slow today? Why are you so slow on this featured video on my podcast? Come on. While we're waiting, we're going to get some coffee. It's just not wanting to play. Let's see. I'm going to reopen. Here we go. Here we go.
Out for a little jog here with the Helix team at Figure.
Look at that guy.
Humanoid robot out here. Do a little running. Probably about 2 meters a second.
Wow.
This thing could go for hours.
That's a military march right there. Just doing a slow run. You know how hard that is.
This is
God.
Full reinforcement learning controller that's fully steerable.
All right, hear that? Full reinforcement controller that is fully steerable. And that's how Figure is running. And I like to tell you guys how these bots, how their brains are working. What does that mean? A full reinforcement, that was bear with me. Fully reinforcement fully reinforcement learned controller and fully steerable. So what that means is just the basics of Figure, as I have gone over this before. And so I think you know this by now, but let's go over it again because I just love talking about it. But Figure, Helix is Figure's in-house AI, and that's how Figure runs. That's how the brain of Figure, that's the brain. That Figure brain, she bowdy. She bowdy over there. She running, she bowdy. So Figure's brain, Helix, excuse me. Let's see. It uses a two-part AI brain called Helix, and that's a two-part engineer architecture. System 1, System 2. Not all robot brains are made this way with this specific stack, okay, with this specific AI stack. So we have the System 1 is the fast action, System 2 is the slower thinking, running entirely on the robot itself, no cloud needed for real-time decisions. The fast part is the small neural network, about 80 million parameters. Oh, that's so small. That runs on high speed. That's 200 times per second. It handles quick, precise physical movements like moving joints, balancing, walking, running, turning, grasping, or jogging. It's a visio-motor policy. The System 1, which is the fast part of the Helix brain, and I'm talking about figure running out there. It's called a visio-motor policy, and that's the name for it takes in camera images what the robot sees and other sensor data, then directly outputs commands to the robot's motors, joint torques, or positions to make the body move smoothly and naturally. So then we have a policy reinforcement learning. Okay, so again, Brett said, I'll play that again. Brett Adcox was running with the robot, that military style, that hard military style.
One cool thing is this is a full reinforcement learning controller that's fully steerable.
A full reinforcement learning controller that's fully steerable. Now, you think controller like a Nintendo controller, some other type of controller. No, that's not what we're talking about here. What we're talking about, all right? A policy and reinforcement learning. Again, fully reinforcement learning controller. Reinforcement learning policy is simply the learned decision-making rule. It's the trained neural network that says, given this situation, sight, balance, speed, goal, do this action next. For the jogging video, this policy was trained entirely with reinforcement learning. In a physics simulation, not in the real robot world, not in this real world. So reinforcement learning is when the AI tries millions of movements in virtual worlds and gets rewarded for the good ones. That's that natural gate. That natural gate get rewarded for a natural gate. And what does a robot, a reward look like? And that might be like a zap up the beach and that little electric zap. And that might feel really good. That's his dopamine hit. Not much different than human beings. They got that little spark in their robot brain. And if it's running with a good gait, it's like very good. That's a good reward. But if it's running with a bad gait, then it gets a bad reward. Points deducted. You don't get a brownie tonight, boy. That is the mother from the Bronx. That's that love, that tough love. That's that reinforcement learning is that tough love from the mother from the Bronx. Okay, I'm going to be out working. You're 9 years old. Make your own dinner because I got to pay your rent. That's what we're talking about. So this thing, Helix, is made on this reinforcement learning, and it gets rewarded for that good gait, that slap gait, staying balanced, following speed turn commands, and penalized for bad ones, falling, wasting energy. You waste some energy, boy. I just gave you some energy when you had that good gait, and now you're wasting it. I'm going to use your hands as ashtrays. That's what's going to happen. So that's that reinforcement learning. After training the policy defers directly to zero shot to the real robot without extra tweaks. I'm going to go over zero shot a little bit later. That's basically, it has to do the thing. So listen, we'll get into that later. Okay. So System 2, System 1, the fast part of Helix, Figure's brain. System 2 is the slower part of Helix, Figure's brain. It's a much larger neural network, about 7 billion parameters versus the System 1, which has 80 million parameters. Okay, so System 2, the slower part, has 7 billion parameters. It's a vision language model. That's a VLM. Pre-trained on internet data and fine-tuned on robot examples, it runs slower 7 to 9 times per second. Now the System 1 was running at 200 times per second. So, and it handles understanding the scene language commands. Jog next to me. Pick up that box. Planning steps and reasoning. It outputs high-level guidance like a compact task plan or steering direction that feeds into System 1 to condition and direct the fast actions. So the two systems are trained together end to end, so they are common language, latent representations for smooth handoff. End to end, folks, that means basically, let's see, traditionally bots had a vision box, planning box, and a control box. Helix, that VLM, maps the pixels from the cameras directly to the torques in the motors in one unified neural network. This is what gives the robot its fluid, non-jerky, human-like motion. So for the running and jogging demo, specifically the 3-minute uncut video, that's how long this video is. So I'll keep playing it here. They're doing that military march. You ever do a military march? Have you ever done a military march? That's where you are in unison. And you can't get off going super fast. You might start off and you're like, I want to go really fast because your body just want to go. Your knees just want to take off on that march. Like, come on. Because that feels good. That feels good to just get going. But you go on a military march, you know what doesn't feel good? This. Oh, your atoms are vibrating in you like, come on, let's go. You can't do it. You're in unison. And you can't be taken off. You got to stay with the group. This is how you stay with a group. And guess what? You're getting tired because your joints, you're not able to move them to its fullest extent. You're not able to fully run with your joints. Guess what? Doesn't matter, boy. Don't be lagging behind because then you're going to keep the whole group lagging behind. And that's not good. You're going to keep the whole group. They're not going to be there. You're going to just get them way behind. Do you want to be that person? Do you want to be that person? So that's what Figure's doing. We're just doing a military march. Bing, 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 bah, bah. They're still going. They're still going in this video. Is Brett saying anything over here? Let's see. They're passing the Figure headquarters.
We're about to get another 4 hours, so.
Bing, 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 bing. Robot's got another 4 hours, so keep going, guys. I mean, you guys look tired already after like a minute, so strap on your battery packs and let's freaking go, man. That's what Brett's saying over there. Brett Adcock, please consider me to run with Figure in a charity race. We're going to go ahead and raise funds for animal shelters. And also, we will raise funds for robotic school programs in areas, usually rural areas, or cities that do not have the budget for a robotic program for the children to learn. They don't have access to the technology to teach the children how to survive in the future, which they need to understand how these things are made. And Brett Adcock, please consider me to run alongside Figure in a charity race to raise funds for those robotic and engineering programs at schools that don't have access to these technologies, and also to raise funds for animal shelters in the area. That would be fan-freaking-tastic. And yes, I did run in a military run. The little military jaunt. I was, guys, once upon a time, for a hot minute, a lifetime ago, I was in the Marine Corps Officer Candidate Program. And I was all ready to go ahead, and I did the workup, the physical workup. I had to pass all the physical tests. You do a little O course. That's the obstacle course where you run, and you got to run over these big old logs. And I'm short, so I would smack into those logs, and my my chest, my ribs, they be a little bit bruised. And that's what happens. And then I got a promotion at work, which was a finance place that I was working at. And they gave me an office with a window, and they increased my salary. And I just couldn't refuse that over getting my rib cages bruised every single day. So that's what I did. That's the direction I went. So, but anyway, I did run in formation like this, and I can do it. I also have awards for running 5Ks and half marathons. That'd be fun. Guys, what do you think? Would you like to see me in a charity race with figure alongside? We're running to raise funds for animal shelters. I would love that. Freaking love that. Come on, let's go. All right. I'm still talking about Helix Brain. I have another view of figure running. Let's see, here we go. This is going to be slow. I think it's going to be slow. So let's get back to Helix Figure's brain and how it's doing this for the 3-minute uncut video, which I just showed you guys. What's mostly running is the system 1 is doing the work. That's that small neural network with about 80 million parameters. It runs at high speed 200 times per second. And it is mostly working off of that system 1. The reinforcement learning trained locomotion policy handles the bipedal running balance, endurance, hours without tiring like humans, and steerability. So, and that's what Brett Adcock was talking about. It's a fully reinforcement learned controller and fully steerable. So I just explained what reinforcement meant and the steerability. So a reinforcement learned trained locomotion policy handles the figure running balance, endurance, hours without tiring like humans, and steerability. System 2 might provide simple velocity goals if needed, but pure locomotion like straight curve jogging runs largely on the fast visuomotor policy alone. And let's see, that visuomotor policy again is it takes camera images what the robot sees and other sensor data, and then directly outputs commands to the robot's motors, joint torques, or positions to make the body move smoothly and naturally. So we got that Jetson Thor brain, the GPU in Helix. And I know that Helix figure over there, they work with Jensen Huang. Again, Jensen Huang, just mentioned him a little bit ago. He's that CEO of NVIDIA, and he makes those chips. Those GPUs, and those chips are freaking mind-blowing. Yo, people said, this can't be done, Jensen. You cannot make a chip where that works on a humanoid or a robot, because a humanoid is it's trained on FP32. Okay, this is the problem with people making robots. It was hard to make a robot before, to have it function properly, because there was no real chip that was easy enough for the AI to run on the robot itself. And I'm gonna explain this to you. AI is usually born in FP32. FP is a floating point operation, and that is a math calculation with a decimal point. And it's FP32, and that's a high precision thinking model. That's a high precision AI, and that is usually what an AI is trained on. Okay, lots of data, it's thinking about things, it's computing, and it's highly calculating. And that 32 bits, that's what that stands for. So so that's what an AI model like Helix would maybe have been ran off of, probably a lot more bits than that, Helix, but just for simplicity's sake, we'll bring it to FP32, and that's a lot of bits. That's high precision. You're going to have a lot of latency with that if you try to put an FP32 bits into a humanoid brain. There's going to be a lot of latency. It's going to be like highly accurate, like 100% accurate, but it's not going to be able to walk very fast it's going to be like snail slow. Snail slow, okay? Not turtle slow. You know what? I'm going to bring that down to sloth slow. That's what FP32 would look like in a humanoid brain. A lot of latency. So Jensen Huang made it possible with his Jetson Thor T5000 module GPU chip. He made it possible to put that chip into a humanoid, and you can now go ahead and use your AI model that was trained in FP32 bits, and you can go ahead and slowly transform it into a FP 16-bit, an 8-bit, a 4-bit. There is a transformer engine in there. It's like an automatic shifter that goes in between all the bits. But you can't just take a model that was trained in high precision, like 32 bits, and then put it in a humanoid brain that's like 4 bits. The humanoid brain, is going to go, the humanoid brain would just completely whack the frick out, man. It freaked out. So before this chip, the Jetson Thor chip, it was very hard, and it wasn't very accessible to do that. And that's why you're seeing all of these really cool, amazing robots now, humanoids like Atlas, Figure, able to run, to do these things. So Figure, I know that Brett Adcock over there, he worked with Jensen Huang. Brett Adcock over there, he's the Luther Vandross of robots. He's so smooth with them. And then he's working with Jensen Huang over there. He's the black leather jacket wizard of Silicon Valley. They're working together. And so you got Helix using that Jetson Thor brain. Okay, so AI is usually born trained in FP32, that's that floating point operation. That's a math calculation with a decimal at 32 bits high precision. But AI lives its daily life inference thinking in FP4. We're knocking that down to a 4-bit right there. The transition between those two is called quantization. So quantization, and that's when that transformer engine comes into play, that automatic shifter in that Jetson Thor T5000 module. We got the Figures Helix. You can think of it as the blueprint and the Jetson Thor as the construction site. The problem, in the past, if System 2, remember Helix is that System 1, System 2 architecture. System 2 is the slow part of it. The big 7 billion parameter model. If System 2 was thinking too hard, it would hog all the electricity and processing power, causing System 1, which is the fast reflex thinking, to lag. If the reflexes lag, the robot fails, which is what I was saying before. It would just be a lot of high latency, and it's just going to fail at everything. The solution is the Jetson Thor uses a multi-instance GPU technology. It allows Figure to physically slice the chip into two. This wasn't very possible before. It was possible, but it wasn't very accessible before. It wasn't scalable before. That's what Jensen Huang made this chip scalable. They put the slow System 2 in one slice and the fast System 1 in another. So, I mean, that is insane. You know, Jensen Huang over there, they're like, hey, this is not possible. We can't do this chip, this Jetson Thor T5000 module with 32-bit, 16, 8, and 4-bit. You cannot do it. And Jensen Huang over there, he's like, you know what? I think I can do it, and I'm gonna do it. And now, you see this chip? I did it. I did it. See this? See this chip? See all these chips? He made it scalable. He went ahead. You know what Jensen Huang did? I'm going to use a pool table. I'm talking pool like you playing pool. He went ahead and he ran that table. He took first place. He took his winnings. That's what he did. And that's what I'm about to do with my comedy. I'm bringing it back, guys. I'm bringing it on back. I know you love it. You love it. You love it out there. We're going to bring it out. We're going to bring it on back. Okay. So this, I'm still waiting for this. Okay, here we go. Finally. This other video of, it's just another view of figure running. It's a, well, I was going to say it's a back view, but the other one was also a back view. It's just more figure running, which, gosh, I want to see. Let's go. Oh, come on. Here we go. He's walking, and now he's going into his run. That's a good way of just kind of rolling right into it, figure. That's a very good way. So, I love that little cadence. Wink, wonk, wink, wonk. Wake up in the morning, every day, every day. You see the sun a-coming, Let's go out and play, Work up, let's go. Figure running, let's do a charity run. Do, 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 do. That's my cadence. That's what I be singing with figure over there. So, this is just so cool. I could just see in the future and like the near future, if you're a lady runner, you got this bot next to you running, no one's gonna come up to you and make small talk with you. That's all I'm saying. And then if you put cover technology into figure. Cover is another one of Brett Adcock's company. I think he's the co-founder of Cover. And Cover is a technology that I think Brett Adcock is working on getting into schools. It is a technology that detects weapons. And you put that cover into figure, and now you got yourself a metal bodyguard. And I will take that. I'll take a whole fleet of them. Yes. Okay. So figure running. Just one more thing on that. We're talking about the drift effect. I'm still talking about the chip that makes it possible, that GPU that is in figure, the NVIDIA Jetson Thor. I believe it's the T5000 module that has all of the floating point bits on there. So you can't just throw away the FP32 math. I'm talking AI is born, usually trained in FP32, okay? Floating point operation, a math calculation with a decimal. 32 stands for the bits. It's high precision. Okay, high precision, high latency. All right, that's what I'm saying. It's not necessarily high latency, but you throw that into a humanoid, you're going to have high latency. So you can't just throw away the FP32 math. Even when figure is running in FP4, that's 4-bit warp speed, it uses an FP32 scaler. That's called to prevent the drift. Think of the FP4 math as a map drawn on a napkin. All right, we got a napkin, we got a map. It's fast and handy, but it's not perfectly to scale. The FP32 is the master ruler. And every few seconds, the transformer engine, that automatic shifter between bits, it pulls out the ruler, the FP32, to make sure the napkin map, which is FP4, 4 bits, hasn't drifted too far to the left or the right. If the robot didn't have the FP32 anchor, the tiny rounding errors in the fast math would multiply until the robot eventually missed picking up a mug by 3 inches. So you need all of that. You need all that to happen, be going down, in order for the robot to be running with this smooth gait, low latency. That's a slap gait, low late. And that's what figure is over there. So there's something called dynamic quantization, and I mentioned quantization just a little bit ago, and that is, quantization is when basically something is condensed, okay, quantization, right? Makes sense. Quantum quantization is condensed, dynamic quantization. this is what the transformer engine does every single millisecond. That's that transformer, that automatic shifter in the GPU. I'm talking the Jetson Thor T5000 module. The transformer engine, that automatic shifter between all the bits. It does this quantization every single millisecond. It looks like a chunk of 16 numbers, the microtensors, and basically it looks at those numbers and says, okay, these numbers are simple. I'm translating them to FP4 for the motors, but then it sees a complex movement like the robot's finger feeling the weight of, say, it's picking up a kettlebell. And it says, wait a second, this is too detailed for a 4-bit. I'm switching this specific calculation over to an 8-bit or a 16-bit so I don't drop the kettlebell. And that's amazing. That is amazing. It's not an all or nothing. The brain can be 90% in a floating point operation for bit, which is fast, and then it could be 10% in the FP32, which is precise at the exact same moment. That is right. That's the chip. That is what this chip is doing in this humanoid brain. You know, the thing is, I think human brains, they have an automatic shifter in there. You know, they got that transformer engine, but sometimes when I'm going to reach for the refrigerator door, sometimes my transformer engine, it doesn't switch over from my 4-bit, from my super fast. I'm just walking over to the refrigerator. I'm not doing a lot of calculations. So I'm on a 4-bit motion right there. I'm on a 4-bit, that's what I'm locked into. I'm on a 4-bit gear when I'm walking over to my refrigerator. And sometimes my transformer engine, it doesn't compute and it doesn't switch over to a higher precision because sometimes I'll miss that door. I mean, it doesn't happen a lot, but maybe like twice in my life where I go to reach the refrigerator door and I'm off. I'm just a little off. I go, that was a terrible representation. No, you kind of get thrown back a bit because you're expecting the weight of that handle. So you're like, and then splat onto the back wall. Bink, bink. So yeah, my transition, my automatic shifter, sometimes it don't work, you know, sometimes it don't work in that human brain. So we need to get a little bit higher precision. We need to get a little bit higher. We have to be on a higher working level. Well, you got to take your vitamin D. You know what I mean? The vitamin D. You got to take your vitamins to make sure that your shifter, your bit shifter is working in your engine. That's all I'm saying. The reason companies like Figure pay for this full chip, this Jetson Thor T5000 module with all of those bits, okay, with all the high precision gears is future proofing. So if the robot encounters a brand new task like folding a shirt it's never seen, it might need to retrain itself a little bit on the fly. Training requires high precision FP16 or FP16, excuse me. If the robot only had an FP4 chip, it would be stuck with what it already knows. It wouldn't be able to do zero-shot learning. That's what we'll get into that in a minute. Having the high precision gears means the robot can actually get smarter while it is working in your house or factory. And then also Helix, the whole reason for this too is to scale up. We're gonna scale up. Because if you got your robot able to learn on the fly on the device itself, then you can have it upload to the mother brain. And that is Helix in the case of Figure. The mother brain is the AI brain. That's Helix. So all of the robots that were doing tasks that day or running, like this Figure running, then it uploaded what it has learned on the fly that day to the mother brain Helix. And then all the robots, then Helix goes ahead and quantization it. I didn't say that word. Quantizes it. It goes ahead and it processes all of that information that all of the figures have learned that day, all this new stuff. Helix is like, this is great. Let's get all of this in a file. And then we're going to send all of these new things that everybody learned. We're going to send all of these new skills out to all the other robots. And now all the other robots are smarter because of it. And that's all because of the capabilities of this NVIDIA GPU. Isn't that yes. Okay. We have a little more. I think I have another view of this. Do I have another view of this? Let's see. Figure running. Oh, this is kind of an interesting clip. Let me just go over my notes real quick, make sure I didn't leave anything out. Well, so just to wrap this up with figure running, the reason the robot can jog naturally alongside people for minutes, 4 hours, according to Brett Adcock, turning, matching speed, never stumbling, is because its fast brain, the System 1, is a single learned reinforcement learning policy that controls the legs, arms, balance, end to end, and that means the AI system learns the entire process in one continuous chain, from raw input like camera images or voice commands straight to the final output like moving the robot's joints or legs, without separate hand-built middle steps or modules that humans have to design and connect manually. So this thing is trained end to end. It was trained in simulation with trial and error rewards for human-like motion, then put straight on the real robot figure. The slow brain System 2 understands commands and the world, but isn't micromanaging every step. All of this runs on that NVIDIA Jetson Thor chip, which we just went over, inside the robot that handles huge AI calculations quickly and efficiently, so it reacts in real time without lagging. And I think that was zero-shot adaptation. Yeah, and so that brings us to AI figure train this purely in super realistic computer simulations using reinforcement learning. The AI tries running millions of times virtually, gets rewarded for looking human-like and staying balanced. Then the exact same learned network gets put on the real robot and just works. That's called zero-shot transfer. And that brings us to our next topic, which is the SkildAi brain, and this is insane. They have something called zero-shot adaptation. So let me just go over zero-shot learning and transfer. Zero-shot learning or generalization. The AI is when the AI model can handle new tasks or recognize unseen data without extra training, relying on its prior knowledge. It's based on machine learning. We just learned all about that. Specifically deep learning, where models are trained on broad, diverse data sets to infer patterns across context. For example, a model trained on millions of images or text can identify a new animal or answer a novel question by connecting it to learned concepts. No new examples needed. Think of it like a kid guessing what a zebra is after seeing horses and stripes. That's what zero-shot learning is. Now, we're talking zero-shot transfer is often called a sim to real. So that means taking an AI model trained entirely in a computer simulation and dropping it into a physical robot body figure where it works perfectly the very first time without any additional training or fine-tuning in the real world. So basically, figure has never ran before in the real world. It only ran in simulation, and then they did a zero-shot transfer, and then they put figure from the simulated world, and they're like, here, they put it in the parking lot out in the wild, and they're like, go, start moving your legs. Figure, come on. If you don't move your legs, we're going to have to move them for you. And then figure's like, oh my God, let me start running. And then it started running. and that's zero-shot transfer, and it does it perfectly with that good gate. Figure does it that perfectly with that slap gate. And it's never ran in the real world in a parking lot ever before. It only did in simulation. That's zero-shot transfer. Okay. Zero-shot learning is about recognizing concepts, basically, and zero-shot transfer is an AI model trained entirely in computer simulation and dropping into the physical world. So zero shot, bink, 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 bink. That is used all over the robotic brain world. Zero-shot learning, zero-shot transfer, zero-shot generalization. 0, 0, 0. This is when zero is a good thing. It's actually a really great thing. Okay, I think, yeah, so, and then speaking of that, we got the SkildAi brain, and they use zero-shot adaptation. What? What are the zero-shot learning, zero-shot generalization, zero-shot policy, zero-shot transfer, and now there's a zero-shot adaptation? What? Yes, zero-shot adaptation. So now we have Skilled. I've talked about Skilled before. They make a AI brain, and their whole shtick is that they had a breakthrough GPT moment, like a chat GPT moment for robots. Basically, until now, robots were data starved because they had to be handheld, teleoperated to learn anything. SkildAi brain is the android of robots. Basically, they're making an AI brain that can fit into any kind of, most kinds of physical AI. So basically, you have an AI that is trained and learned in simulation, and it is not learned by being teleoperated. A lot of companies will pay people to go out and wear a headset, and it's going to record everything you're doing. Like, you're going to do the dishes, you're going to go work out, and then you tripped. Oh my God. And this is all the footage that the robots, they learn from. Because the reason why people are doing that, and people and robotic companies train people to do that, is because we don't have a lot of that data in the world. There's not a lot of data. There's a lot of text data out there on the interwebs, but there is not a lot of people putting GoPros on their daily life and like working through the physical world in, the physics of it all. There's not a lot of that at all. So now we got to get that footage, and it's just not scalable to have people wearing these things and record and then trying to teleoperate a robot, meaning you have like a joystick or some haptics and you're moving your hand and then the robot's moving its hand, or the video I showed of the guy, he was kicking and the robot was doing the same movements as him, and the guy didn't realize he was in the line of fire of the robot's foot to his groin when he kicked, and then he got hit in his groin. And both of them went down. Both the robot and him went down because the robot did whatever the guy was doing. That's teleoperation. It's just not scalable. So SkildAi went ahead and they're like, hey, let's just do this. We'll put YouTube, we'll sit our AI baby in front of the YouTubes, and they can just learn like that. And then also this brain that's going to learn off of the YouTubes, you could put that into a humanoid, a bipedal, a two-leg thing. You could put that into the ostrich thing. You could put that into Salto, our little bouncy dink with the rotors. Or you could put that into a quadruped. You could put that into a robo-dog. You could put that into Wally. You could put that into Eva. So, and you could put that into any kind of physical robot, and then the AI brain will figure out how to go about using its body because it was trained with physics in mind, and that is very mind-blowing, and that is SkildAi, and that is your freaking mind blow out your butt. That's what level of mind-blowing this AI brain is. It's wild, man. This is what's going on in January of 2023. Thanks. Holy smokes. God help us all. God save all the company. Okay, so that's what Skilled is doing. They have the core breakthrough, omni-bodied intelligence. Most AI is built for a specific body, and that's okay. You know, like Helix, Figure, and Tesla's Optimus, they are mostly building specialists. That's what their core value is. That's what their company is all about, and they're doing that for a specific reason. They want a humanoid that is perfect at being a humanoid. Their data is often high fidelity, meaning they use expensive sensors to track exactly how a human moves to copy it perfectly. If you tried to put Figure's brain into a 4-legged robo-dog, it would likely fail because it's optimized for a 2-legged humanoid. So that's the difference here that we're talking about. So this core breakthrough of the SkildAi brain is the omni-body intelligence. Most AI is built for a specific body. It only knows how to be a humanoid. So if you put I just talked about that. Put it in something else, it will fail. SkildAi created the omni-body foundation model. This means the brain is detached from the hardware. It learns the laws of physics and movement rather than how to move these specific motors. So it has that zero-shot adaption. When a robot encounters a task or a body it has never seen before and figures it out instantaneously without being reprogrammed. So you don't have to reprogram it every time you put this AI brain into any kind of different physical body. It's a vision language action model. It's a model that can see a cup, the vision here, pick that up, language, and move the arm, which is the action with it. And it's sim to real, of course, simulation to reality. That's how any kind of modern if you want your robot, your humanoid to be successful, you're going to have to train it in simulation to reality. And if you can afford it, do it in NVIDIA Cosmos. That's like the gold. That is the gold standard. I do believe the Cosmos World Foundation model. It's just like very turnkey from my understanding. So they make it very easy for you to get on down the road with your robot training so you can get your robot out there in the physical world faster. And the wild thing is, let's see, the diffusion secret sauce is scaling. So a SkildAi uses massive amounts of low quality internet. Okay, so this is the wild thing. SkildAi, like I had mentioned, they, instead of having their robots look at this like high quality videos of people going about their day and like doing things, they use sort of like low quality YouTube videos, but it's a way for them to scale. So their secret sauce is scaling using massive amounts of low quality internet video rather than just high quality lab data. And it's just wild. SkildAi is like a kid who watches 10,000 hours of Bruce Lee movies and then walked outside and knew Kung Fu without ever being taught. That's the SkildAi brain. That's what the SkildAi baby is doing right now. It's sitting and watching a ton of YouTube videos, and then it can go outside in the real world and do it. That is wild. I mean, it's just, whoa, man. We're moving towards a world where robots spend millions of years dreaming in simulations so they can be experts the moment they wake up in your house or a factory. And so in NVIDIA Cosmos, I'm moving on to a world model where the robot is trained. Robots practice in a synthesized world. So Cosmos synthesizes robot data for the robots to learn, and they practice it's called dreams. It's called an AI dream, the synthesized data. So the robots practice in these synthesized data worlds at 1,000 times the speed, and then they fail, fall, try again in this dream until they master the task. It's called physically grounded learning. Physically grounded learning, generalization through dreams, simulations that randomize the weight, friction, and gravity of objects. The robot develops a gut feeling for physics. That's what that world model is. It's not just in some weird simulation world like, Minecraft, where these dudes are in there. There's no like physics. They're just floating about and everything. No, this thing, like you pick up a kettlebell in Cosmos, and you're going to feel the weight of it. Your body, your hand gonna go down. Your hand, your shoulder, you're gonna tear some labrums. You know what I mean? If you don't brace yourself. So that's what this NVIDIA Cosmos world is doing with the physics. When the robot in this NVIDIA Cosmos world sees a kettlebell, when the robot sees a kettlebell in the real world from the simulated world, okay? The AI recognizes the object's properties from its training. It knows that a 20-pound kettlebell requires a specific torque in its motors and a shift in its center of gravity before it even lifts it off the ground. That is wild. That is just mind-blowing. Holy smokes. Wow. Okay, so this other, figure is running. I have one more figure running video because we can't, that's not gonna get old. Figure running, that's never gonna get old, right guys? Let's watch more figure running. That makes you want to run in formation. Ding, 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 with ting, ting. Oh, Salto should be next to them. That'd be so fun. Or have a little ding, ding next to running in formation, like ping, ping, ping. I would love a little Salto running with me. That little one-legged bouncy bounce. So that little one-legged bird over there, it's got his leg up under its feathers to keep it warm, and then it's just bouncing up and down with its two rotors. That's Salto. Okay, but I'm going to show you this video of Figure. I'm imagining them all in the same world now, like together. They are in the same world, but now I'm imagining them together. So kind of like a Star Wars world. So we got Figure running and someone stops and yells out the window at Figure. And this is basically, I feel this way sometimes when I do a set, when I'm trying to work through material in a place that maybe they aren't too keen on technology and robots. They don't know me. They're not used to me. They haven't warmed up to me. And when I go to talk about robots and AI, people start coming out the shrubs with shifts. And that's the feeling I get from this video. Here we go. Is he gonna, okay. So Brett says, ignore the guy yelling out his car window. Those things are going to kill us one day. Oh, that's fantastic. Thanks, Bert. Those things. Here we go. Ready? Those things are gonna kill us one day. Thanks, Gary. Kill us one day. Thanks, Braxton. God, come on. That's why I talk about this with you guys on here about how these robot brains work and about the CEOs of the company, just so you have a little bit of background and then you can form the opinions you want to form on here about it all. So I have a robot here of, if you're going to train your robot and you got your robot laid out on the floor and then you're like, okay, stand up, robot. Just remember, put it on some carpet or make sure you train your robot in simulation if you're going to have it on some slick floor. So here we go. This person put their robot on a slick floor. And this is the result of it from not training it on a slick floor in simulation. Oh, come on. Oh, it's struggling. Good God. It's kicking, it's struggling. It's like, what do you guys do? Why would you do that? Could you imagine waking up for the first time? And you're like, who are these people? Oh my God, I gotta get out of here. And then you're trying to get your footing. You're like, oh my God. And then you're just like, bash your head against the floor. And you're just arms flailing. I mean, this is horrific. Just remember, robots have a really good memory. Don't put them on a slick floor when you wake them up for the first time. Mother Teresa, Lord help us all. I think on that note, I'm going to end this podcast. It was a really fun time today with you guys. I had so much fun. I hope you had fun. And I will see you next week, guys. Bye.